Welcome back. Today, we are tackling one of the most challenging areas of data science: high dimensional complexity. In our dimensionality reduction lab, we transform hundreds of variables into intuitive 2D or 3D maps. As chapter 4 of our manual explains, we aren't just squashing data, we are seeking to preserve the underlying manifold structure. Let's start with the digits dataset. These are high dimensional images that are impossible for a human to visualize in their raw state. Notice our curated built in datasets, perfect for benchmarking model performance. Next, we choose our reduction engine. You have access to PCA for linear variance preservation or nonlinear powerhouses like TSNE and UMAP. For this run, we'll stick with PCA to establish a global baseline. Your controls are here in the sidebar. We can set our target dimensions, usually 2 or 3 for human visualization. You can also toggle whiten to uncorrelated your components, as discussed in the SVD interpretation of our manual. With one click, the transformation is complete, but here is where Visual ML Lab Pro differs from standard tools. We don't just show you a plot, we give you the trustworthiness score. This metric quantifies how well local neighborhoods were preserved. A score of 0.816 tells us that 81% of our neighbors in high dimensional space are still neighbors in this 2D map. This is essential for ensuring your visualization isn't lying to you. We also see the explained variance ratio. This tells us that our 2D map captures roughly 21% of the total information contained in the original dataset. Look at the PCA embedding. Each color represents a different digit. Even in 2D, we can see natural separation starting to form. By visually inspecting these clusters, you gain an intuition for data separability before you ever train a classifier. On the right, we have our scree plot. This bar chart shows the information load of each component. Notice how the first two components carry the most weight. This visual helps you decide if a 3D embedding might be necessary to capture more structure. As always, every run is recorded in the experiment log. It tracks your algorithm choice, components, and results. This allows you to benchmark PCA against TSNE and UMAP side by side to find the most trustworthy view of your data. Export your embeddings as high-resolution PNGs or pull the full log into Excel for your research report. Visual ML Lab Pro provides the bridge between high-dimensional math and human-safe decisioning. Visit qilabs.in to start your journey.